On Friday, you're going to be taking a buggy car quiz, and so I want to work out what it is you're supposed to know before you actually do that. And this will show you, demonstrate to you the power of mathematical models and why we use them in science and in physics and so on. So the best way to do it is just set up the situation. Here's a flat surface. It's going to be the floor of my room. And we're going to put, let's say we put 2 toy cars on here. Now these cars are going to be a little different than our buggy cars, just because the speeds are going to be faster. So here are 2 like little radio-controlled race cars or something like that. And we're going to point them at each other. And I think it's easy to see that if I were to release these cars, let them go at the same time, but one of them is going to go in this direction and one of them is going to go in this direction, that if they're on the same track and they're all lined up and they go straight, what's going to happen? They're going to collide. Now, what do we mean by collision? We mean that these 2 cars are going to try to occupy the same position at the same time. Okay? I've seen some of you try that in the parking lot out here, the student parking lot. You're trying to occupy the same position at the same time, and that's why we don't want you in our parking lot. Okay? But anyway, now what you're going to be able to do is to create mathematical models for these cars. And I've just come up with this example. I'm going to call this car A and this car B. And so let's say that car A has a velocity of 2 meters per second. So pretty fast. I've just picked numbers that are easy to do the arithmetic for. Okay, and let's say that its starting position is at 8. Well, let's put 0 way over there. So we'll say this is at 8 meters. So when time is 0, the position of car A is 8 meters away from our origin, and it's moving in the positive direction at a rate of 2 meters every second. Okay, makes sense? Now let's suppose that we measure everything we need to know for car B. So here's our mathematical model for car B. And let's say it's going really fast. -4 meters per second. The negative means it's going to the left instead of the right. And every second it goes 4 meters. That's like a medium running speed is about 4 meters per second. So if you're jogging pretty good, that's about 4 meters per second. So this is a little faster than our toy cars. And then let's give it a starting position, just to make the numbers work out nicely, of 20 meters from our origin. Okay, now I want to be able to predict when and where these cars are going to collide. And this is the power of the mathematical models. If I have a good, accurate mathematical model that describes the position of the cars as a function of time, I can predict exactly when they're going to collide. Let's look at it graphically, though, first. Let's just draw a real quick position versus time graph. And I'll just go 1, 2, 3, 4, 5 seconds. Now, at 5 seconds, this guy's going to be at 18 meters. At 0 seconds, this is at 20. So 20 is good enough. So 5, 10, 15, 20. So this will be position in meters. Okay. And so if I draw car A, well, it starts at 8, which I'm going to put right there. And then at 5 seconds, it's going to be at 18. So that's right about in there. So I can cheat a little bit and just draw a straight line like that. And there's the graph for car A. Now, car B starts at 20, And then in 5 seconds, well, you've got negative 20 plus 20, it's at 0. So it's going to be right there. And so, well, let me just do that like this. Okay, so I try to draw a straight line there. Now, this is a rough hand sketch, and so it's not perfect, but that's where the collision is going to take place on the graph, where they intersect. Because here they're at the same place at about the same time. Same time, same place. Collision. Okay, now it looks like it's about 2, maybe a little more, 12, 13 meters, something like that. But what is it exactly? We can get it really much more accurately from this. Because what's happening right here? And here, I look over here, and the position of car A is equal to the position of car B when we have a collision. Does that make sense? This little mathematical expression for saying they're at the same place, x sub A equals x sub B. The position of A is equal to the position of B. But if this is true, then what I can do is I can say, oh, look, then, well, but the position of car A is 2 meters per second times time plus 8 meters. But the position of car B is negative 4 meters per second times time plus 20 meters. So if the position of A equals the position of B, then this expression has to equal this expression. You follow?
Yes.
Now, what's the advantage of doing this? Well, now I've got an equation, but there's only one unknown in the equation, and that unknown is time. Yeah. So I can now solve for time using algebra. All right, so what I'm going to do is I'm going to solve for time. First thing I'm going to do is I'm going to add 4 meters per second times time to both sides. And I get 6 meters per second times time plus 8 meters equals 20 meters. Okay? And then I'm going to subtract 8 meters from both sides. And I get 6 meters per second times time equals 12 meters. And now I'm going to divide both sides by 6 meters per second. And of course that goes away, and I'm left with time equals, well, 12 divided by 6 is 2. Now let's take a look at this. This is a compound fraction with the units. This is meters divided by meters per second. What happens when you divide by a fraction? You reciprocate and multiply. Remember that from 6th grade or whatever? Reciprocate and multiply. I'm going to reciprocate meters per second and multiply seconds per meter. So what happens to the meters? They cancel. You have 2 seconds. So now we know that the time is 2 seconds. That's when they collide. Where do they collide? Well, how do I figure it out now? I just plug it into one of the equations. So let's look at car A. And we have 2 meters per second times 2 seconds plus 8 meters. So the seconds cancels the seconds. 2 times 2 is 4. 4 meters plus 8 meters. According at 2 seconds, car A will be at 12 meters. Now we can check to make sure that that's actually where they collide by plugging that into car B. So negative 4 meters per second times 2 seconds plus 20 meters. Well, again, the seconds cancel. Negative 4 times 2 is negative 8 plus 20 is 12. Woohoo! They agree. So we know that at 2 seconds, both car A and car B will be at 12 meters. They will be colliding. Now here's what you're going to have to do on Friday. I'm going to give you a car. You're going to figure out what its speed is. Then I'm going to have you place the cars. I'm going to tell you what starting position to put your cars. I'm going to match you up with another group. You're going to have a mathematical model for your car. They're going to have a mathematical model for their car. And as a mega group, you're going to have to tell me when and where they're going to collide. It's worth 10 points. If you're within 0.2 of a second when you actually do it, you get 5 points. For every 0.2 of a second off after that, it's minus 1 point. Then you have to be within 10 centimeters of the position. If you're within 10 centimeters, you get full credit, get another 5 points. But for every 10 centimeters you're off from that, it's a point off. And most people will get 100% on it. But you have to make very accurate measurements and do a good job. And everyone will have to show their work. But that's what you're going to do. So I want you to practice doing this. And that's what the worksheet's going to be. Let me see. And I'll pass this out in a second. But now number one, this is just for car A and for car B. You can put them on the same graph if you want, but I just want you to figure out how fast car A and car B go. Then in part 2, one of the cars, car B, you're going to turn it around. So its velocity is now negative rather than positive, and you're going to make car A and car B collide. And so by answering these questions, you're going to figure out where they're going to collide. So that's all there is to this assignment, and I think you'll be able to finish it in class if I pass the worksheet out in time. Okay, so that is all.